Okay, so physicists have been waiting for this since way back in 1916. It's a big deal because it gives us a peek at something super weird: black holes. These things are famous for being strong but hard to spot. Even though they pull on stuff a lot, we can barely see them, which makes them mysterious. The one they're talking about might be like 2 to 4 million times bigger than our sun. Over the past few decades, what we know about black holes has changed a lot. We used to know nothing, but now we're starting to get a good look at them. And now, physicist Michio Kaku says we've actually managed to look inside one. This could give us tons of information and help us figure out things we missed before. Let's check out black holes and see what's inside. Space is huge, but black holes bring up a lot of questions. Before we get into Kaku's crazy findings, it's good to know the basics. Most people know a little about black holes, but there's still a lot we don't get. The idea of black holes started in 1916 when Albert Einstein came up with his theory of relativity. He thought black holes might be real, but it was just a theory. About 50 years later, in the 1960s, we started finding proof they were out there. Researchers saw a bright blue star in the Cygnus group that was shooting out X-rays. The star wasn't still, it was circling something big and dark. When they looked closer, the X-rays were getting sucked into this thing. That's when they started calling them black holes. It was a huge moment because it showed black holes weren't just in Einstein's head. They were real things in space, and we needed to study them. Scientists all over started looking at a black hole in Cygnus called Cygnus X1, which is about 6,000 light-years from Earth. It was super bright, way brighter than the sun, and so dense that not even light could get away. That's what makes a black hole a black hole. Black holes are cool and scary at the same time. They're spots in space where gravity is so strong that nothing can escape, not even light. If anything gets too close, it gets sucked in and disappears forever. That's why we need to figure out more about them. After Cygnus X1, researchers started hunting for other black holes. Now they think there might be over 100 million in our Milky Way galaxy. But since they're hard to see, we don't know for sure. What we do know is that there could be millions of them, which means they're a big deal for space research. The main worry with black holes is their gravity. It's so strong that anything nearby gets squeezed super tight until it's just a tiny point. They're like cosmic vacuum cleaners, sucking everything in. One of the messed up things about black holes is that if you fell into one, you'd get stretched out like taffy. It would kill you before you even got close to the center. So, yeah, stay away from them. Even though the closest black hole is pretty far away, it still makes you wonder if they're dangerous to us. In 2021, scientists did something awesome. They took the first clear picture of a black hole in the M87 galaxy. They took a bunch of pictures and put them together to get a good look. Turns out, a black hole isn't just an empty space. It has 3 parts. The first is the event horizon. Once you cross this, you're done for, no turning back. The second is the photon sphere, where light gets stuck circling the black hole. If light goes in there, the black hole grabs it and it can't escape. The last part is the singularity, where everything gets crushed into a tiny point. The laws of physics don't work there, so who knows what happens. What's even weirder is that no 2 black holes are exactly the same. They all have those 3 layers, but they act differently. Usually, scientists use telescopes to see stuff in space. But you can't see black holes, so that doesn't work. They can only study them by looking at the radiation they give off and the stuff around them. Sending probes like Voyager is out of the question. Anything that crosses the event horizon is gone. So scientists have to study them from far away with telescopes. One idea about how black holes form is that they're made when stars collapse. When a star runs out of fuel, it falls in on itself and can create a singularity. To learn more about black holes, NASA scientists zoomed in on the middle of the M87 galaxy. They saw a huge swirl of superhot hydrogen gas spinning super fast. It should have flown apart, but it didn't. Scientists figured that something really heavy, maybe 2 to 3 billion times the mass of the sun, was holding it together. The only thing that could be that heavy is a black hole. But black holes might not just come from collapsing stars. Way back in 1963, a mathematician named Voyager used Einstein's equations to explain how a spinning black hole works. He said that instead of collapsing into a point, it would form a flat disk called the ergosphere. The ergosphere is a place where the laws of physics start to get weird. Kerr also said there might be something called an Einstein-Rosen bridge, or a wormhole. This would be like a tunnel connecting two different spots in spacetime, and maybe even two parallel universes. If you fell into a black hole, you might go through this wormhole and end up in another universe or another time. To get how a wormhole works, think about spacetime. Einstein said that space and time are connected, making a four-dimensional thing. Heavy stuff warps this, creating gravity that pulls things toward it. Imagine spacetime as a piece of paper. If you put two dots on it and draw a line, that's how things move through spacetime. But if you fold the paper, you make a shortcut between the dots, like a wormhole. Wormholes aren't just in movies. They're what Einstein's theory says could happen. But nobody's seen one, and they're probably not steady anyway. They'd probably disappear right away. The idea of using wormholes to travel through time and space has had physicists excited for years. It's cool to think about going super far super fast, but it's tough. Einstein said nothing can go faster than light, which makes wormhole travel hard, at least with what we know now. Recently, a type of wormhole called the ER wormhole has got people thinking. It would connect two faraway spots in spacetime, maybe even different universes or times. Some people say it might not be steady or you couldn't go through it because of all the radiation and weird stuff at the quantum level. Some physicists say that Einstein's equations don't explain the quantum forces that control tiny particles. To really get these things, we need a new theory that combines quantum mechanics with general relativity. It's a theory of everything that could explain how the universe works from the smallest to the biggest things. Michio Kaku has been working on this theory for a long time. One idea is superstring theory, which says that all particles are actually tiny vibrating strings. In this theory, the universe is like a symphony with different particles being different vibrations of these strings. Superstring theory could also explain black holes, wormholes, and other crazy things by showing how these strings bend spacetime. Even though it sounds good, superstring theory is still just an idea. It needs extra dimensions of spacetime that we can't see yet. They might be so small that we can't find them. Some people think these dimensions were bigger at the start of the universe during the Big Bang, and then they got smaller as the universe grew. Superstring theory could explain black holes, wormholes, and spacetime, which is why it's so cool. As we try to figure out spacetime, black holes, and the universe, there's still so much to learn about reality. We're just starting to understand black holes and what they're really like. Michio's work with string theory is just starting to give us possible answers. We've got better pictures of black holes with telescopes, but there's still a lot we don't know. Theoretical physics, black holes, and spacetime are still being studied a lot, and there's a lot more to explore. Besides changing spacetime, black holes are important for talking about how the universe started. String theory says that universes colliding could create new ones, and black holes might be part of that. Maybe our universe came from two other universes crashing together, or maybe we're living inside a black hole. That would turn everything we know about the universe upside down. If that's true, it would change how we think about the Big Bang. We might start thinking of black holes as creative things that lead to other places or universes. While black holes being portals to other universes or time travel is cool, it's still just a theory. How wormholes work and how to travel through them is still a big mystery. Even if wormholes are real, the radiation near them might make it impossible to go through them. Some physicists think if we could make a wormhole steady, we could travel through time or between different places in the universe. But that's a long way off with what we know now. Also, when we look at black holes with quantum mechanics, we find even more questions. Particles act different at the quantum level than what we see normally. And the laws of physics don't seem to work with black holes. This difference between quantum mechanics and general relativity is one of the biggest problems in theoretical physics. Superstring theory might help by adding extra dimensions and explaining gravity better. But it hasn't been proven yet.